Welcome to the class, my dear students. We are doing the applications of integrations. In the previous lectures, we have done how to find out the area between the curve and the x-axis, how to find out by using the integration methods. Similarly, find the area between the curve and the y-axis and the area between any two curves we have done with the volume, and now I'm going to do to find out the length of an arc by the method of integration. So now how to find out the length of an arc. So for this, the first thing we have to understand, and let us recall the definition of the distance between any 2 points of a line segment. For example, if I ask you what is the length between the points AB of a line segment. Now let us say the point is x1, y1 is the point A and x2, y2 is the point B. Okay. Now the distance between A and B, or the length of the line segment AB, what is that? That is given by, in your high school you would have learnt, what is that? x2 minus x1 the whole square plus y2 minus y1 the whole square under root, correct? So this is what the length of the line segment, which is AB. Now let us rewrite this whole thing like this. Let us see now. I want to divide this by x2 minus x1 the whole square, let us say. Then what happens? x2 minus x1 the whole square over x2 minus x1 the whole square plus y2 minus y1 the whole square by x2 minus x1 the whole square. So I am dividing by x2 minus x1 the whole square, suppose. Then we can write like this. Understood? And now what is this? This is nothing but both of them are the same, right? It gives you 1 plus y2 minus y1 by x2 minus x1 the whole square, correct? Now, what is this y2 minus y1 by x2 minus x1? This is nothing but the slope of the line segment AB, where y2 minus y1, the change of y-axis, the change of the function when there is a change in the function in the x-axis. So it is nothing but the rate of change. So we can even write this as the rate of change of y with respect to x. So I can replace this whole thing as this x2 minus y2 minus y1 by x2 minus x1. I can replace it by dy by dx because it is the rate of change, okay, over 1 under square root of 1. So, and now this is for a straight line of the line segment AB. This is what you can say. Now when I talk about the arc length, that means the length of this arc AB, means what we do is we just draw some tangents at a particular point of this. Let us draw a tangent at a particular point. Let us say like this, suppose. Then what happens here? Okay. At the same time, one more straight line we will be, one more tangent at another point. Let us draw one more tangent at another point. Let us draw one more tangent. So whatever the distance between A to B, when I consider that, I know the length of the line segment is given by square root of y2 square root of 1 over 1 plus dy by dx the whole square. So I want the length of the total arc from the points now. Let us say now the point is from x is equal to A to x is equal to B. So that means what it is? The length A to B. At this distance from A to B, what is the length of the arc is given by such type of the distance from this point to this point, this point to this point, like that. So when you do the integration from A to B, it is 1 plus dy by dx the whole square under root dx. So this is what the formula for understand for the to find out the to calculate the arc length. So this has come by using this method of finding out the length of a line segment. So let us remember this. So it is square root of 1 plus dy by dx the whole square dx integral a to b. So this is what the arc length. Okay. Let us now come to the problem. What is the first problem now is to find out the arc length. Let us see here.